So electric power is generated by installing a hydraulic turbine generator at a site 700 meters below the free surface of a large water reservoir that can supply water at a rate of 1,500 kg per second steadily. If the mechanical power output of the turbine is 800 kilowatt and the electric power generation is 700 kilowatt, so we need to determine the turbine efficiency and as well as the combined turbine generator efficiency of this plant. So we need to neglect the losses in the pipes. So given sa atin yung figure, so given, and also the elevations. We all know that, right, given, we have the elevation at which that is 700 meter from point 1 to point 2. This is open to atmosphere also, the water, and the rate of the water, supply water, which is 1,500 kilogram per second. So we have the mechanical output of the turbine. So the work of the turbine is equal to 800 kilowatt. Okay, so this is the work of the turbine, 800 kilowatt. This is the output, and also we have the power generation. Okay, power generation from the generator, electric generator. This is also the output, 750 kilo. So the required here is the efficiency of the turbine and the efficiency of the turbine generator. Solution. We all know that the energy of a mechanical system of a fluid is equal to the mass times the quantity. What are those? In mechanical energy of a fluid class, in the lesson, excuse me, we have the so-called flow energy, the pressure over the density, plus the change in flow energy, the change in flow energy plus the change in potential and the kinetic energy. Take note that the flow energy is equal to the pressure over the density. The pressure here at point 1 and point 2 is open to atmosphere. Automatically, the change here in pressure is automatically zero. And also the potential energy at point 1 from the surface, so this is positive. From point 2, we have here the elevation at point 1, potential energy at point 1, and the potential energy at point 2 is 0. So this is the point 2 elevation, yeah. And also the kinetic energy, since the kinetic energy at point 1 is also equal to the kinetic energy at point 2. So this is also equal to 0. Why? Because since the water from point 1 is essentially motionless, wala ditong pwersa. So automatically lang siya bumababa. Parehas lang dito. Parehas sa kinetic energy of the water at turbine exit. So, this is the turbine exit. So, assume negligible. So, ang matitira na lang ng mechanical energy ng fluid natin is equal to the mass flow rate times the, so 0 yung potential energy natin, ito 0, 0, sa potential energy matitira na lang ito, so gravity times the elevation at point 1. So the mass flow rate is 1000 kg per second times the gravity 9.81 meter per second times the elevation 70 meter. Convert it into kilojoule or kilowatt. Diba? So automatically we need to compute for this. Kilogram mass per second is Newton meter per second. So joule lang to. Joule per second ang matitira. So convert natin into watt. So 1 kilowatt 1000 watts. Okay, so the mechanical fluid now, the energy that is from here, the total mechanical energy of the fluid is 1,500 times 9.81 times 70. Divide natin siya ng 1,000 to convert it into kilowatt. So we have now 1030.05 kilowatt. So this is now our mechanical energy of the fluid. But the required is the turbine efficiency and the turbine generator efficiency. So we all know that inefficiency is equal to always output over input. In the turbine, finding for the turbine, what is the output? So given sa atin yung output niya of the turbine, yung output niya over the input at the turbine. Take note, the work output is given, so 800 kilowatts over, ano yung input natin dito? Since we are talking about fluid, so sabi nga, the mechanical fluid now, so ang input natin ito is 10,000, 30.05 kilowatt. So we have now the turbine efficiency, which is equal to 800 divided by 10, 1000, 30.05 kilowatt. So makakompute nyo is 0.7766. Automatically, since efficiency is always in percentage, express your answer in percentage. So we have 77.66%. This is now your efficiency of the turbine. While the efficiency in the turbine generator, ano yung output natin? Since alam natin, combined na siya, so from here, generate na ng electricity, ang turbina, may output dito. Ano kaya yung output dito sa generator? So, ang output dyan, since this is a combined efficiency, we need to find the output of this turbine generator. Since combined siya, hindi naman yung lalagay natin yung output lang ng turbina. So, we need to put the electric generator output. Siya na yung tunay na output natin kasi siya yung sa ulihan. So this is the generator output, or that is the electricity produced for the input of this total input or the tinatawag nating mechanical energy of the fluid. So we have now here the generated electric power generation, so 750 kilowatt over the 10,000, 30.05 kilowatt. So the efficiency of the turbine generator is equal to 750 divided by 0.5. So we have now 0.7281. Ang sabi ko nga, always express your answer in percentage when computing for the efficiency. So we have 72.81%.